Hi guys, welcome back to this series on interest and depreciation, and today we're going to be looking at compound. Now we've looked generally at what interest is in the past few videos, but so far we've only really examined simple interest in detail. So what is the difference between this compound interest and simple interest? Now just to show you the difference between a compound interest and a simple interest, we're going to consider two banks. The blue bank is going to pay interest on your account that has $1,000 in it once a year. So let's just say right at the end of the year, the blue bank will pay interest of 10% on your $1,000 in the bank. The red bank, however, is going to pay you also 10% per annum, so once a year, so 10% every year on your $1,000, but they're going to pay small parts of this 10% every month. So they're going to pay this 12 times. So remember, because this is per annum, it doesn't mean they're going to pay 10% every month. They're going to pay 10% divided by 12 because there are 12 months, because they're going to take this 10% in 12 little bits. So one for every month. They're going to pay you a small portion of this total 10% every month. So the question here is, which is the better deal? So we're going to look at both situations, both for the red bank and the blue bank, and we're going to see which one is better. So to compare these two banks, what we're going to do is we're going to assume that we both have the same amount of money, so the same principal we're starting off with of $1,000, and there is no new money going in and there is no new money coming out. So as we said before, we're going to have to figure out, this is paying monthly, this 10% per annum. So it's going to pay this bit by bit. So 10 divided by 12 is going to be paying you 1.2% per month. This one over here, however, is just going to pay you 10% flat per year. So what we're going to do is we are going to assume that this blue bank pays the money at the end of the year, and we're going to compare how much money is in our accounts at the end of the year and see which one is better. So month 0, so we haven't started the year yet, we have $1,000. Now month 2 in the blue bank, you're still going to have $1,000 because they only pay you the interest at the end of the year. That 10% only comes at the end of the year. So, but this bank, as we found out before, is paying us 10 over 12%, which is going to be 0.83% every month. So if we use our simple interest formula of PRN, we get 1,000 for our principal, 0.83 for our rate, and 1 for our N because it's only 1 month. They're paying this 0.83 every month. So remembering that the 0.83% in decimal form is going to be the same as 0.0083. Because remember, this percent here is the same thing as divide by 100 or out of 100. So if we put that into our calculator, 0.0083 times 1,000, we're going to get our total interest of $8.30. So in our bank account, the total we're going to have after month 2, different to this other bank over here where we still have the same $1,000, we now have $1,008.30. So after month 2, we can see we've got $8.30 more than this $1,000 over here. Now for month 2, so that was month 1 here. For month 2, the bank now, instead of paying interest on this $1,000, has to pay interest on what's in my account. So they have to pay me interest on the $1,008.30 in my account. So over here, it's a different story because they still haven't paid the interest. They still only need to pay me the interest at the end of the year on this $1,000. So because we know they're not going to pay interest at the blue bank, till the end of the year, we still have this $1,000 with no interest earned because we're going to get our interest paid right at the end of the year. So that's month 0, month 1, month 2. Now with the red bank, we are again going to have to use our interest formula of PRN, and we already know that this N is going to be 1 because we're paying it for another 1 month, and this rate is going to be in decimal form the same as before, so 0.0083. And this principal now has changed because instead of $1,000 like it was at month 0, it's now $1,008.30. Now, if you put this into your calculator over here, then you'll see that this month you're again going to get $8 of interest, but this time you're going to get 36 cents on top of that because the principal was bigger than it was in the last month. Now I've rounded to 2 decimal places over here, but as you can see, I've added the money that was in our account before, plus the interest that we got this month in the bank. So as we can see, our money's already started growing a fair bit in the red bank, but it's still staying the same in the green bank. So we'll do it one more time before we accelerate to the end. So again, in the blue bank, we still have the same $1,000 because the bank only pays that interest once a year. Now in the red bank, however, again going to get that little piece of that 10% per annum. So we're going to get that 10 over 12% paid every month, which as we know in decimal form is 0.008. But our principal now, so remembering our formula PRN, our N is just going to be 1 because we're paying it for another month. Our rate's going to still be the same thing. This number here, we know it in decimal form, but this P is now going to be the money that we have in our account, which is going to be $1,016.67. So it's this P that keeps changing. Now, if you put that into your calculator, you'll see that this time we get $8.74 roughly paid of interest. So as you can see, every month, because the P keeps going up, we get more and more interest. So this time I'm going to add on my new interest I got paid for month 3 back onto my money that I had in my account in the first place, and that's going to give me a new total of $1,025.41, and again that's rounded to 2 decimal places. So continuing on with this pattern, changing the P in our PRN until we get to the end of 1 year. So remember, this was month 0, this was month 1, this is month 2, this is month 3, and comparing it to the blue bank, which is going to stay until we get to the end, we can see the following pattern. So month 0, I start with $1,000. Month 1, I have $1,008.33. Month 2, I have $1,016.73. Month 3, I have $1,025.20. Month 4, I have $1,033.74. Month 5, I have $1,042.35. Month 6, $1,051.04. So we're halfway through the year now. Month 8, $1,068.62. Month 9, I have $1,077.52. Month 10, I have $1,086.50. And month 12, the end of the year, I have $1,104.67. Now, if we compare this to the blue bank that only pays 10% once a year at the end of the year, then we know we're just going to have 1,000, 1,000, 1,000, 1,000, 1,000, 1,000 until we get to the end of the year, and they're going to pay us our interest, which is 10% per year. So they are only going to do their PRN once. They're going to have their rate of 0.1, which is in decimal form of 10% or 10 out of 100. A principal of just 1,000. That is not going to be going up. And their N is they're only going to pay it once a year. So remember, our N is in years, our R is in years. They're paying us 10% per year, and they're paying us for 1 year. So in total, their interest is going to be $100. Now, if we add our interest plus our principal, which will give us the total money in our account at the end of the year, we can see we only have $1,100 at the end of the year. So as we can see, the red bank is better, and the reason why this red bank is better is because it is doing something called a compound effect. Now, compound means combined. So the reason we can tell it's compounded is because the P, instead of staying the same like it is at the blue bank, it keeps getting bigger. So the amount of money, so the interest, is being paid on top of interest that has already been paid. So there's combined interest in the red bank that adds to give us more money at the end of the year. And this effect will only get bigger and bigger the amount of time we go into the future. Now, if you want to have a look at how this looks when you change the principal or the frequency it gets paid or the number over a longer period of years, or even with the different interest rates, you can head over to the compound interest calculator at the moneysmart.gov.au website. So we can see that there's a difference if we change this from monthly to yearly or annually. So you earn more the shorter the time period is between interest rates. Now you might be thinking to yourself, how do I calculate the end amount of interest without having to go through every single month and calculating PRN? Well, there is something called a compound interest formula. So our compound interest formula works a little bit differently. So because our old one just told us the amount of interest only, this new formula is going to tell us our new principal. Or in other words, P plus I. So we're going to call that A. Now A is going to be equal to the principal, so the same thing as up here, the initial amount, but this time we're going to have 1 plus our decimal rate to the power of n, which is going to be our number of time periods that this rate is paid over. So again, as we went through over in the simple interest formula, it's important that this n and this r are both in the same time frame. So if the n is the number of months it's given over, then the rate needs to be in the number of months. If n is per annum, then rate needs to be per annum. So to get an idea of how this formula works, we're going to check that we get roughly the same answer as we did before, of $1,104, and we got 71 cents, but remember we were rounding, so that doesn't really matter. We want to try and get something close to this number if we consider our 10% per annum paid monthly for the red bank. So does this formula give us the same answer that we got when doing every single month one by one? So let's have a look. So our A, we hope, is going to be that $1,104. Our P is going to be the amount we had at the start, so that's going to be our $1,000. We're going to have 1 plus our decimal rate, and remember our rate, because it's getting paid monthly, is going to be 0.0083. And our N is going to be 12 because we're paying this monthly over 12 months to get to our 1 year period. So if I put this in my calculator, I'm going to have 1.0083. I'm going to do this bit first to the 12, put that in first, and then times it by your 1,000. And you are going to get, and I get $1,104.27. And that is pretty close to what we got before. And the only reason that's going to be different is because we were rounding along the way as we were going on. Whereas this uses this exact rate and it takes account of the exact numbers without rounding. So as we can see, this formula gives us the same answers if we were to do PRN for every single month until we got to the end.